This is an article from phys.org. Forces from Earth's spin may spark earthquake and volcanic eruptions at Mount Etna. New research suggests forces pulling on Earth's surface as the planet spins may trigger earthquakes and eruptions at volcanoes. Seismic activity and bursts of magma near Italy's Mount Etna increased when Earth's rotational axis was furthest from its geographic axis, according to a new study comparing changes in Earth's rotation to activity at well-known Italian volcano. Earth's spin doesn't always line up perfectly with its north and south poles. Instead, the geographic poles often twirl like a top around the Earth's rotational axis when viewed from space. Every 6.4 years, the axes line up in the wobble phase for a short time, until the geographic poles move away from the spin axis and begin to spiral once again. This phenomena, called polar motion, is driven by changes in climate due to things like changing seasons, melting ice sheets, or movement from tectonic plates. As polar motion fluctuates, forces pulling the planet away from the sun tag at Earth's crust. Much like tides due to gravitational pull from the sun and moon, the tide from polar motion causes the crust to deform over the span of seasons or years. This distortion is strongest at 45-degree latitude, where the crust moves by about 1 centimeter or 0.4 inches per year. Now a new study published at AGU's journal Geophysical Research Letters suggests that polar motion and subsequent shifts in Earth's crust may increase volcanic activity. I find it quite interesting to know that while climate drives Earth's spin, its rotation can also drive volcanoes and seismicity, said Sebastian Lambert, a geophysicist at Paris Observatory in France and lead author of the study. The new findings, however, don't allow scientists to forecast volcanic activity, although the study suggests earthquakes might be more common or volcanic eruptions may eject more lava when the distance between Earth's geographic and rotational axis is at its peak. The time scale is too large for meaningful short-term forecast, according to the authors, but the result point to an interesting concept. It's the first time we found this relationship in direction from Earth's rotation to volcanoes, Lambert said. It's a small excitation process, but if you accumulate all excitation over a long time, it can lead to immeasurable consequences. Previous work has shown the length of a day on Earth, which changes based on the speed of Earth's spin, also deforms the crust and could affect volcanic behavior. In the new study, Lambert and his colleague Gianluca Scotli, a volcanologist from Spenza University of Rome in Italy, wanted to study the relationship between polar motion and volcanic activity. They focused on Mount Etna because the volcano is well studied, meaning there's plenty of data and it sits just south of a 45-degree latitude. There also weren't any volcanic crises out of the ordinary at Mount Etna during the study period, which might otherwise mask a signal from polar motion. Lambert and Scotili used seismic records from 11,263 earthquakes that happened within 43 kilometers or 26.7 miles of Mount Etna's summit between 1999 and 2019. The team also used records of how much magma erupted from the volcano since 1900. They included 62 eruptions in analysis based on the time span between events. The pair then compared the distance between the geographic and rotational poles at the time each event occurred to determine whether volcanic activity was connected to Earth's rotation. Lambert and Scotili discovered there were more earthquakes when the Earth's rotational pole was furthest from the geographic axis, at the point in Earth's top-like spin when it looks like it's about to fall over. Between 1999 and 2019, those peaks were in 2002 and 2009. An expected peak in 2015 never materialized because one of the oscillations contributing to polar motion has been slowed down. The team also uncovered a link between the amount of magma ejected during an eruption. Polar motion appears to drive the largest eruptions from Mount Etna, although to a lesser extent than its seismic activity, according to the researchers. Examining volcanoes in the Ring of Fire to see if Earth's spin impacts their activity would surely be interesting, Scotilli said, who was senior author of the study. Even expanding to other planets might open scientists' view of how external forces impact volcanoes on the surface, he said. If you like this article, please leave a link below, or leave a comment below, and I will leave the link below the video for those who would like to read it. Hi guys, NCWQ here, and there was a magnitude 3.3 earthquake in the greater Los Angeles area in California. It was 8 kilometers deep and 3 kilometers northeast of Brea. And we're going to look this up on Google Earth here. This was a 3.3 magnitude earthquake. It struck the area Saturday morning and was posted by U.S. Geological Survey and EMSE. This earthquake hit at 9:23 a.m. about 2 miles northeast of the Orange County suburb. The depth of the quake was 4.85 miles. And looking at all the info, residents in Brea, Diamond Bar, Fullerton, Rowland, Pomona, and other surrounding areas all reported feeling this jolt. Anyways, you guys, this is interesting. This looks like a housing area here, and I was thinking that was really close for these houses to be to this earthquake. Anyways, you guys, hope you all are doing well, day or night, wherever you are in the world, and much love.